Hi, in chapter 4, you learned about the integral, right? That is the opposite of the antiderivative or the inverse process of the derivative, right? And another name of the integral is antiderivative. And also you learned some of the formula about the antiderivative, and also you learned substitution method, right? In chapter 5, you learn about how do we find out the antiderivative of exponential function, the function involving log, and also the inverse functions and inverse trig functions, right? On this chapter 7, we will learn about the application of the integral or application of the integration, okay, or antiderivative. You know that the integral of a function fx dx basically finds the area under the curve fx between a and b. The definite integral is basically the area under the curve fx between a, the lower limit, and upper limit, okay, and above x-axis, okay, under fx and between a and b. That's the area under this curve above x-axis. This is x-axis, right? So that's what the definite integral of a function fx, right? Now, if you have two functions and if you want to find out the area under two between two curves fx, y equals to fx, and y equals to gx, if you want to find out the area between these two curves and between a and b, x equals to a and x equals to v, then how do you find out that? Is basically, if you find out the integral of a to b fx, it will find out the whole area under fx, right? Similarly, if you find out the area under the gx, that will be that white area between a and b, white area, right? But if you subtract this white area from the overall area under fx, that will give you the area between this fx and gx, right? That's how to find out area between the function fx and gx, where fx is bigger than gx in that interval, okay? Here fx is bigger than gx. If gx is bigger than fx, if gx was top and fx was the bottom function, then you would write gx minus fx at that time, okay? So if fx is bigger than gx or equals to gx at that time, what you do is to find out the area between fx and gx, you always do fx minus gx. That is area under f minus area under g, where f and g are continuous functions. If there is a break, then the story will be different, okay? Since fx is continuous, gx is continuous, if you want to find out, and fx is bigger than gx, and if you want to find out the area between those two functions fx and gx, and between x equals to a and x equals to v, two vertical lines, at that time the area of the shaded region is a to b fx minus gx, and then bracket outside there is dx, okay? All right, let us do some examples here. So this is example number 4 from the book, okay? Find the area of the shaded region. This is that shaded region here. You see that? That's that shaded region here. So here, for this shaded part, which function is on the top and which function is on the bottom? Obviously, this line is above on the top part of that shaded region, and that curve is on the bottom part of the shaded region. So for this, so the area will be, so we need to find out this curve, okay, this point and then this point first. How do I find out that? So to find out this point on question number 4, it is graph is given there. The graph says that this is like 1, this is 1. So this coordinate on the graph is -2, -2, +1. That's the coordinate of this point. And another point has coordinate 2, 9. That point is 2, 9, okay? That is given in the graph of question number 6. Now you see that? So again, to find out the area under two curves, we need to find out what is the left boundary of what is x equals to what number on the left boundary, and x equals to b is on the right boundary. So what is the x value on the left boundary? It is basically you are trying to find out area between these two, right? So a is -2, sorry, x is -2 here, right? X equals to a is x equals to -2, and this is x equals to +2. Okay, so the area will be -2 through +2. What is the upper curve in this interval? That y2 is bigger than y1, right? Because y1 is on the bottom part of that shaded region and y2 is on the top part. But outside that, y1 is on the top and y2 is on the bottom. But we are not concerned. We are not focusing on the outside region. We are focusing on that shaded region only. So -2 y2 minus y1 and then dx. You see that? So if you do that, then -2 through 2, y2 is 2x minus 5, and then minus y1 is x squared plus 2x plus 1. And then there is dx, right? So there is a negative sign before that parenthesis, so we need to distribute that. So you get -2 to 2, 2x minus 5, right? You don't need parenthesis here for the first function, and minus x squared minus 2x and then minus 1. I'm just distributing that negative sign. You see that? And then there is dx here. Okay, now there you see that there is -2x and +2x, so they cancel out. So let me write down that function in the nice format, -2 to +2. You see that? And then what is that? -x squared, and then -5 minus 1 is -6 dx. That's what you got. Okay, now what is the integral of that? So the integral of that is basically -x cubed over 3 minus 6x, and the limit is -2 through +2. Now plug in the upper limit for x and then do minus and then plug in the lower limit, right? So what do you get here? You will get -x cubed, sorry, -2 cubed, right? Negative 2 cubed. So you will do -2 to the cubed over 6, okay, minus 6 times. By the way, the first one is +2, okay, and the minus 6 times 2, okay, and then minus. Now you need to plug in -2, right? So let us plug in -2. -2 to the cubed over 3. I'm sorry, that should be 3 on the first one, right? Not 6. So this will be 3. So 3, okay, this is positive there, okay, and then minus 6 times -2. You see that? Now if you simplify that, what do you get? You get -2 cubed over 3. How much is that? So there is negative sign, and then 2 cubed is 8 over 3 minus 12, okay, and then minus how much would that be? -2 cubed is 8, but there is -8 times negative will be positive 8 over 3, right? And then minus 6 times -2 is plus 12. You see that? How much do you get? Is, oh, by the way, I messed up one sign there. Did you figure that out? That should be plus, okay, that should be plus sign, so that will make this one plus, this one plus, this one plus, and then here as well. So all other things are same. This one will be plus, and then this one will be plus as well. So what do you get there? So you got -8/3 plus 12 minus 8/3 and then plus 12, right? That's what you get. Now you see that if you distribute that negative sign, you will get -8/3, -8/3, okay, plus 12, and then minus 8/3, and then plus 12 as well. So what do you get? That is -8/3 minus 8/3 is -16/3, right? That is -16/3 plus 12 is 24. 24 minus 16/3 is how much? That is basically, if you use calculator, So 24 minus 16 third, or you can say 24 is 72 third minus 16 third will be, I think that you will get 18. Okay, let me double check. So 24 minus 16 over 3, I got 18.66. okay, that is basically, if I find out the fraction of this, I get 56 over 3. I got 56 over 3. That is the final answer. Okay guys, that's what it is. All right, let us see another question, which is question number 12 from the book. That's the question number 12 from the book. Now here it is given that 2 to 3 x cubed over 3 minus x over 3. So you don't need to actually draw the graph here. Okay, it is just straightforward here. All right, so I mean, if you draw the graph, it's not a big problem. You can definitely draw the graph using your calculator. Okay, so if you draw the graph of this, it will look like between 2 and 3 only. So you are drawing the graph between 2 and 3, so it will look like the line x over 3 will look like this. Okay, and then the other curve between 2 and 3 will look like that, and then this is like 2, this is like 3, and then you will be basically finding that area. Okay, so that is x cubed over 3 minus x. This is x over 3. So either way. Okay, now to find out this, again you need to integrate just like that. So this is equals to, what is the integral of x cubed over 3? So that is 1. So let me write down that 2 to 3, and then 1 over 3 times x to the 4 over 4, right? That's the integral of x cubed, minus this is x squared over 2, that is the integral of negative x minus x squared over 2, minus this is 1/3, and then that will be x squared over 2 again. Okay, so by the way, I found the integral already, so I don't need the integral sign since I found the integral already. What I need is, I will write down the bracket and write the limit of integration 2 to 3, like that. Okay, 2 to 3. So when you do that, now let us see what we got. So you got x to the 4 over 12. Okay, and how much is that? So I can keep that, or I can combine that. So you got x squared over 2 minus x squared over 6, right? So if you combine that, you will get minus 4x squared over 6. You see that? Why? Because x squared over 2 is same as 3x squared over 6, and minus 1x squared over 6 will be 4x squared over 6. And now we'll plug in the limit next, 2 to 3. Okay, now let's plug in 3 first. 3 to the 4 over 12 minus 4 times 3 to the square over 6. You see that? And then minus, now let's plug in 2 inside the parenthesis, because you will be subtracting. When you plug in 2, you will be subtracting the whole thing. You will plug in 2 and subtract from that one. Okay, so that will be 2 to the 4 over 12. Okay, and then that will be minus 4 times 2 to the square over 6. Just use calculator, or just you can do manually as well. So that is 81 over 12. Okay, that is 81 over 12, and then 81 over 12 minus 4 times 9 is 36 over 6 is 6, right? And then minus, what is that, 2 to the 4, 16 over 12, 16 over 12, right? And then minus 4 times 2 square is 16 over 6, 16 over 6. Okay, actually in question number 2, it is just asking that you need to sketch the curve and then set the region area represented by that. We already sketched the curve, but again, if you want to find out the integral here, this is not exactly how the question number 12 is worded in your book. I just copied that question, but I asked you to find out the integral. Okay, but in the real problem in the book, it is not asking to find the integral. It is just asking to set, draw the graph and then set the region. That's what it is asking. Okay, but anyway, so how much would that be? That will be, you see that is 81 over 12 minus 16 over 12. How much is 81 minus 16? 65 over 12. 65 over 12, right? And then minus, this is 36 over 6. That will be plus, because when you distribute that, that will be plus 16 over 6. So minus 36 plus 16 will be negative 20 over 6. That's what you got. Okay. Now that will be 40 over 12. So 65 minus 4, because 20 over 6, you can use calculator always. So 65 over 12 minus 40 over 12 will be 25 over 12. If you need to find out the integral, that's what the area, that's what you, or the definite integral, that's what the final answer will be. Okay. The next question is, I'm taking question number 17 from your book. Okay. So you need to sketch the graph. Okay. So you need to sketch the graph of this, and then you need to find out the area as well. All right, guys. So let us do this problem. First of all, you can use your calculator to sketch the graph. Okay. So if you use your calculator to sketch the graph, this is what you will get. You will basically get this curve x squared plus 2x will look like this. And then the another curve is basically x plus 2. So x plus 2 will look like this, like that, and then x plus 2 will look like this. Okay. So if you set, I'm sorry, this is just a single line. If you set the curve, this is what you get. You see that this is x plus 2, g equals to x plus 2. This is f equals to x squared plus 2x. You see that? It is similar to the one we did in example number 6. But always you can use calculator to draw the graph here. So as we did in example 6, you do the area will be area equals to, you do integral. We need to find out a and b. We need to find out that point and that point, that x value and that x value. Okay. And you do g of x minus f of x. How do I find out x values? What is the difference between question number 6 and this problem is, in question number 6 we knew the x values, that point and that point. So we took the x coordinate of that point and x coordinate of the other point, and then we took the lower limit and upper limit. But we don't know that here. So how do I find out? You just solve these two equations. Okay. So how do I solve the two equations here? Is to solve that, you can do x squared plus 2x equals to x plus 2. Why did I do equal? Because at these points and that point, we are trying to find out this point and that point. At these 2 points, this curve and that function, that line and this curve are equal, right? That's why I'm writing this equal to find out that point. So let me move this to the left side. You'll get x squared and then plus 2x minus x minus 2 equals to 0. That is x, take the x common. What do you get? X, or you can just do this way, or you can do like x squared plus x minus 2 equals 0. Now write the fractions. Okay. X minus 2, x plus 2, and then plus. Okay. And then x minus 1 equals to 0, right? We need two numbers whose sum is positive 1, product is negative 2. So what are the values of x? X equals to negative 2, that will be negative 2, and x equals to positive 1, that is positive 1. Okay, this is like negative 2, this is positive 1. So that's what we need to find out the area, just the x values. You don't need y value here, just the x value, because when we do dx, we need the x limits. Okay, when you do dy, at that time you will do the y limit. We'll do some example of that type as well. So that will be negative 2, okay, to 1. Gx is x plus 2, and then minus fx is x squared plus 2x, and then dx. Okay, so let us simplify that. Negative 2 to positive 1, x plus 2 minus x squared minus 2x dx. You see that? So that will be negative 2 to 1, x minus 2x is, let me write down like negative x squared minus x, x minus 2x is minus x, right? And then x squared is negative x squared, negative, and then plus 2, and then dx. Let us integrate it. What do you get if you integrate? You will get negative x cubed over 3 minus x squared over 2 plus 2x. That's the integral of x squared is x cubed over 3, x is x squared over 2 plus 2 is x, right? And then just write the limit, negative 2 to positive 1, like this. Now let us plug in 1 and then do minus and then plug in negative 2, okay? So that will be negative 1/3 minus 1/2 plus 2 minus, let's plug in negative 2. Negative 2 to the q is negative 8 over 3, you see that? And then minus negative 2 square will be 4 over 2, and minus 2 times negative 2 is negative, plus, there is plus, right? Negative 4. Now just simplify, use calculator or simplify that. You get negative 1/3 minus 1/2 plus 2. This is positive 8/3 and then minus, so minus 8/3, and the negative times negative will be positive 2, okay, and then negative, and then negative will be positive 4. You see that? So how much is that? 2 plus 2 plus 4 is 8, and then minus 1/3 minus 8/3 is negative 9/3. You see that? Negative 9/3 means negative 3. So you will get basically 8 minus 1/2 and then minus 3, because negative 8/3 minus 1/3 is negative 3, negative 9/3, that is negative 3, and minus 1/2 is there, and then 2 plus 2 plus 4 is 8, right? So 8 minus 3 is 5 minus 1/2, that will be 9/2. That is your final answer. Okay guys, so this is how you do. Basically it's not hard to find out the integral, because we have been doing the integration for a long time. Only the difference is, first you draw the graph, and then if the graph does not intersect, okay, then you do integral a to b, okay. If they intersect, and if you're finding the area here like that, then you do from left value of x to right value of x, and then upper function minus lower function. If they don't intersect, if you have the boundary, from take x equals to left boundary to x equals to right boundary, the upper function minus lower function. And again this is saying the same thing. If the limits are given, x values are given, use those x values. If the x values are not given, then find out the intersection by equating the two functions. Find the point of intersection, and those will be the limits. So next we will do some more examples on if the graph intersect at more than 1 point, then how do we find out that? Okay, that is the thing that we will be doing next.